Now we are welcome to part 2 of this temperature analysis. Now we said number 12 now. Which of the following is not correct? So what we are going to do now is, they say this one is Celsius to Fahrenheit, Fahrenheit to Celsius, Celsius to what? Okay, let's correct this one. So we have corrected it. Then we have what? Fahrenheit to Celsius. Then we have Fahrenheit to Radian. So what we want to do now is, let us draw this 0 degrees Celsius, this 100 degrees Celsius. This is what 273 Kelvin. This is what 373 Kelvin. We are not dealing with that one. I think we are dealing with Fahrenheit, 32 degrees Fahrenheit, and what 212 degrees Fahrenheit. Then we have Rankine, 492 Rankine. Then we have what 672 Rankine. So having gotten that now, what we want to do now is to convert this TC to what? TF. So TC minus 0, let's convert this one to this one first, over 100. TC minus 0, the 100 minus 0 is equals to what? TF. Similarly, you do the similar thing here, minus what? 32 over 212 minus 212 minus 32, which will give us what? 180. You can write it out. 180 is gotten as what? 212 minus 32. That's how we get this 180. 212 minus 32. Then you cross multiply. TC minus 0 is what? TC. So TC over 100 equal to TF minus 32 over 180. So what I want to do is to multiply both sides by 100. So if you multiply both sides by 100, I want to have it as what? TC equals to TF minus 32 times 100 divided by T by 180 will give us 0.5556. 556, which is same as 0.5556 TF minus times 32 will give us what? 17.78. That is TC. I don't think this one is correct, so it's wrong. Okay, let's make TF the subject of formula. Okay, this one is also the same as 0.56 TC minus 17.78 TC. But if you check option B now, this is what? Sorry, this TF. If you check option B now, TC was attached to 0.56, so it's wrong. So it's also wrong. Let's go to option C. Option C is TF to TC. TF to TC will give us what? TF. Make it TF solid the formula here. First of all, what we want to do is to take this one here first. So it implies that what? That will give me what? CF TC plus 17.78 equal to 0.56 what? TF. Now what do we do to what? That means what I did was bring this one here, become plus, then remain like this. What do we do is we divide both sides by what? 0.56, 0.56, 0.56. So that implies that, well, what do we have? 1 divided by 0.56 will give us what? 1.8 approximately. 80C plus 17.78 divided by 0.56. That is approximately 32. Is equals to this one will cancel this one, we have TF. I think this one is in the option, which is option C. So that one is correct. Let's do between F and Fahrenheit and Rankine. They did not ask us, but let's solve it. That will give us okay, this minus this, TF minus 32 over this minus this is 180. Then we do the same thing, T Rankine. Now we got T minus this because TR minus 492 divided by this minus this is still 180. So this one can cancel out. That means multiply both sides by 180. You have TF minus 32 equal to TR minus 492. So what do we do? So TF equal to, let's make TF such as the formula. Let's take this minus 32 to close the constant. Con TR, don't forget, minus 492 plus 32. So that will now be TR is equals to what? Minus 492 plus 32 minus 460 minus 460 minus 460. Let me check this question and this one again. That means we will be having two answers that are the same for this question. Okay, I think that this one is TF. Okay, so I think D and C will be correct. For this question, we are having two answers. This one is correct. This one is also correct. So for that question, I think we have to leave it because we're having two answers. But if they had made this one, maybe they have made it plus. Let's say we make this one plus now. Then there will not be answer in it. Then you cannot change. But if they make this one plus, this one's plus, then let's say we move it to plus so that we can have an answer. Therefore, C will not be your answer. At what temperature will what? Will Celsius what scale read twice the Fahrenheit scale? This is what Celsius scale. Let's say 100 is 0 degrees Celsius. Then let's have a what? A Rankine scale, a Fahrenheit scale, 32 degree Fahrenheit and 212 degree Fahrenheit. Let's say, and now say at what temperature will what? Celsius scale be two times the Fahrenheit scale. So if the Fahrenheit scale is theta, Celsius scale will not be what? 2 theta. Celsius scale be 2 times the Celsius scale. We Celsius scale read twice. So if this one is what? Twice the Fahrenheit scale, that means if this one read 40, for example, this one will read 80. That's what they think. That this one is, if you read 80, this one is 40, that means the Celsius scale is reading twice this one now. So we can now what? Say this minus this, 2 theta minus 0 give us the 100 minus what? 0. So to theta minus 32. Then this minus this. Just like this minus this is at the numerator, this minus this at the numerator, then this minus this at the denominator, which is 180. So let's play with it. I want to have what? 2 theta over 100 degree equal to theta minus 32 over 180. Let's cross multiply. I would have 360 theta equal to 100 theta. That means this times this 100 minus this size is what 3200. Now what we do is to collect like terms. Let's bring this one here. We would have what 3200 become plus 100 theta minus 36 theta. So what is 100 theta minus 36 will give us what 260 theta minus 260 equal to 3200. What do we need to make a theta zero the formula? Divide both sides by minus 26 minus 260. So theta becomes what? 3200 divided by 260 minus 12.3 degrees Celsius. We have minus 12.6 there, the option. So I'll go for none of the above. Because minus 12.6 and minus 12.3 are not the same thing. So that is what we have minus 12.307. Number 14. The resistance of the element of a platinum resistant thermometer is 2 ohms at ice point, 0 degree, 100 degrees Celsius. This one is what? 2 ohms. Then at ice point, 2 ohms, and 2.73 at ohms at steam point. So what is the temperature of the platinum resistance scale? We read correspond to its resistance value of what? Resistance value of 8.43. 8.43, that should be on top. This on top. 8.43 is higher than what? 8.43. See what temperature on the platinum resistance scale would will correspond to the resistance of what? 8.43 ohms. So we are looking for theta now. So what we are going to do now is you said 100 minus 0, this minus this equal to what? This minus this 2.73 minus 2 divided by what? Theta minus 0, theta minus 0, then 8.43 minus 2, and this minus this. So this one is what we are looking for now. So what I want to do now is to say 100, this one is 100, theta equals to what? 2.73 minus what? 2, it should give us 0.73 divided by what? 8.43 minus 2 was 6.43. You cross multiply. What I would have now 0.73 theta equals to what? This times this will give us what? 643. Then what do we do? Divide both sides by what? 0.73 to make 0.73. 0.73 divided by what? No, 643 divided by 0.73 should be giving us 880.8. So theta will give us what? 880.82, which is about what? 881 degree. Now let's say what the volume of air at constant pressure in a gas is 29 at 0 degree. So this is what? 0 degree, and what is the volume at that point is 29 centimeter cube. Then at 100 degrees Celsius it is what? And 41 at 100 degrees Celsius. Find the volume of the what? At absolute zero. Absolute zero has to do with what? That means I have to use what? Let me convert it to Kelvin. Absolute zero is 0 Kelvin, is 273 Kelvin. Then this is what? 3 373 Kelvin. So let's say now this is where we are looking for now. The volume at this point. So now what I want to do is this. Use so this minus this, or let's say okay 273 minus 0, then this minus this also 29 minus v, the volume so I'm looking for, then 373 minus 273, because we are looking for the volume at absolute zero. Absolute zero is temperature at 0 Kelvin. So 373 minus 273 will give us what? 100 divided by, then if you say 373 minus 273, then you should just also say 41 minus 29, and 41 minus 29. We play with it. That will give us 273 over 100 equal to 29 minus v over 41 minus 29 is going to give us 12. Then cross multiply. So what I want to have now, 273 times 12 will be giving us about 3276. You can press the calculator. Then this times give us what? 2900 minus 100 V. So now what we want to get now, we want to get the value of what? Of volume at that particular what? Of absolute zero temperature. So as you collect like terms, 3276 minus 2900 equal to minus 100 V. If you subtract, you're going to have what? 376 is equal to minus 100 V. If I go start by minus 100 V, so V becomes what? V becomes what? This one cancel this. Minus 3.76 centimeter cube. So that's what I'm going to have for that. The last part for this section, it says what? A certain thermometer registered minus 20 degrees Celsius, minus 20 degree X at ice point. Don't forget, 0 Kelvin is absolute zero temperature, or minus 273.16. Don't forget, 0 degrees Celsius, 100 degrees Celsius. Then we have our upper fixed point. They say minus 20 degree X at ice point and 90 degree X at steam point. Calculate the what? Temperature at what? 50 degree X. So call it theta in degrees Celsius. So what we want to look for now will not be this minus this comparison. Theta minus 0 over 100 minus 0 is 100. This 50 minus 20 is 70 degree S, or let's say 70. No need to put this one after our final answer. We indicate it there. Then this minus this one, I want to have it what? The same. Okay, we can even say 90 minus 20, or 90 minus 50. If you do 90 minus 50, then you have to compare this one. And this one will have to go. This minus this will be under. This minus this will be under. But since you have said this 100 minus this one, we have to compare like compare like. So in that case, 90 minus 20. 90 minus 20 is 110. So we cross multiply. What do we have now? Theta over 100 to 70 over 110. Cross multiply. I would have 110 theta is equals to what? 70 times 1000. So what do we do? 100 rather. What do we do? We are going to have what? 70,000. 110 theta. So 70,000 divided by what? 110. I'm going to have 63.4. So theta will now be 70,000 divided by 110. You have 63.636. This is approximately what? 63.4 degree. So this one will go 63.64 rather. That one will go. So we are done with this part. I believe you enjoyed it.